Hello, this video is about how to use Qt's quality assurance tools as part of an automation stack that supports every phase of your development process. We begin with product requirements, typically managed in tools like Jira or Polarion. Once requirements are defined, development starts in your chosen language and architecture. Once development is done, the testing phase begins. The first testing stage is unit testing, where the developer tests the units of code written to give an early feedback. Qt provides the Qt test module, which allows developers to quickly create and run unit tests, giving confidence that individual components behave as expected. But unit tests alone aren't enough. We need to know what parts of the code they actually cover. Qt's Coco code coverage tool provides cross-platform, cross-compiler code coverage analysis. It instruments your source code and measures coverage at the levels of lines, blocks, functions, branches, and even high coverage levels like MCDC. Coco also supports test data generation, automatically creating new inputs to extend coverage. This is where Coco discovers new test cases by using a genetic algorithm based on an existing unit test to discover the optimal set of input data. Now, once the application is built with an user interface, further tests are executed. Alongside manual testing, Qt offers Squish, a powerful GUI test automation tool. Squish is multi-platform and object-aware, enabling robust automated testing of user interfaces across many UI toolkits. Furthermore, you can run Squish on an Coco-built application to get coverage of the UI tests. With Squish 9.1, the new Squish AI assistant helps analyze and refactor test scripts, making test automation smarter and easier. Beyond Qt's own tools, AI code assistants can integrate into your workflow, helping generate or refine unit tests and Squish scripts using large language models. As manual testing is still an integral part of the testing strategies, Qt tools also allow to integrate those efforts seamlessly in the automation stack. All results from unit tests, coverage, GUI automation, and manual testing are collected in a centralized test result storage database called TestCenter. This provides a single place to connect requirements, schedule test runs, and analyze results. Finally, the entire QA stack integrates with your CI/CD plugin, be it Jenkins, Azure DevOps, GitLab, and others, enabling automated builds, nightly runs, and continuous quality monitoring. So together, Qt Test, Coco, Squish, and TestCenter form a complete quality assurance automation stack, ensuring higher confidence, faster feedback, and more reliable products. In this technical presentation, I'll show you how Qt's QA tools fit into a single automation stack. Qt Test for unit tests, Coco for coverage, Squish for GUI automation, and TestCenter for central results, all driven by Jenkins CI/CD. So the project under test here is spectral analysis. Spectral analysis is a sample lab. It's built out of QtQML that analyzes food samples and visualizes results with charts. To speed up test creation, I use third-party LLM code assistants to draft Qt test cases, then refine them in Qt Creator. In Qt Creator, enable the code coverage plugin, which is inbuilt. For CMake projects, it just adds a Coco plugin.cmake and wires the build to Coco's instrumented compilers. I am building with MSVC, so Coco automatically selects the MSVC compatible compiler and linker. After a clean build with Coco, the first artifact is the instrumentation database, the .csmes file. This is generated along with the standard executables. Opening it in Coco Coverage Browser shows source code and coverage metric by functions, lines, branches, and when configured MCDC. Now I run the app interactively for black box testing. When I exit, Coco writes an execution report, a CSEXE file. I load that report into the CSMES file, and the current run gives about 62% coverage from manual exploration. Next, I execute the Qt test unit tests. That generates another CSEXE file. Importing it merges results with the black box test run to give one consolidated coverage view. Now, to demonstrate Coco test data generation, I switch to a simple C++ example. First, we build the example with unit tests without the Coco test engine, and we open the Coco measurement file generated. We then run the test executable and load the execution report to get only about 53% coverage, which is not great. Now let's rebuild the example, but this time using the Coco's test data engine module, and open the measurement file. We then run the Coco test engine application on the built executable, which generates inputs, here 10,000 tries, and drives the app automatically. The Coco test engine relies on the generator input JSON config that has information on what type of test data is to be generated, and then generates another output JSON config where the test data is generated. After loading the execution report generated by the Coco test engine into the measurement file, you can see the resulting Coco execution report achieves 100% coverage for this sample. Thus, with Coco test data generation, we have achieved 100% coverage without adding more test cases. For UI test automation, we can use Squish to create test cases in multiple scripting languages or other approaches like BDD and model-based testing. In this example, I am using Squish 9.1 to test Qt 6.9 based applications. I have prepared a Python test suite already, which you can hand script or use the record and replay option. While the Squish's AI assistant also helps analyze and refactor scripts. So let's replay this test case. Squish will now launch the application in its context and perform the test cases to get the test results. As we are now testing a Coco built application, replaying the script produces a Coco execution report similar to before when we did black box testing, which means we can import it into the same Coco measurement file and get coverage including black box testing, unit testing, and Squish UI testing all in one file, providing a fully rounded code coverage with more confidence. Now that we have run tests in individual tools, the results are localized to the system where it was run. However, to make the test results public to the team, we can publish results to a common dashboard server with TestCenter. Here we can create a new TestCenter project where all the testing efforts are logged. The coverage results along with the source can be seen, and then also the Squish UI test results. We can also link to requirements from third-party tools like Jira or Polarion, or set up a generic integration to create a requirement table and thus maintain a traceability matrix connecting the requirements to the test cases from multiple tools. Furthermore, TestCenter also provides a way to log manual testing by creating manual test templates and test runs, which can then be executed during manual testing efforts. These results will also be attached alongside automated runs to give a better test coverage from multiple tools. Hence, with TestCenter, you get a global and pursued coverage views, drill downs, and requirement to test traceability for audits and sign off. And then onwards, you can make decisions if the product is mature enough to go to production or back to the developer to fix it with a Jira ticket. Finally, the whole flow runs in any CI/CD system to fully automate the process. In this example, we are using a localhost Jenkins server where we have stages to check out, configure, build with Coco, run unit test, and then run Squish test, and then finally upload all the reports to TestCenter. You can also see the Coco coverage report by exporting the report into an HTML format, which then Jenkins can load. After the build, TestCenter shows the latest reports and updated coverage metrics automatically pushed from Jenkins. So that's the complete pipeline. Qt test plus Coco for coverage, Squish for GUI automation, and then run Squish on top of Coco built AUT to create a coverage report of the UI test. Centralized in TestCenter where all the results are being pushed. Finally, everything orchestrated by Jenkins CI/CD server. With this stack, you get measurable coverage, requirement traceability, and repeatable CI from manual explorations to fully automated UI and unit tests. Thanks for watching.